Welcome. Let's take a look at a couple of examples involving using the product rule in conjunction with derivatives involving the logarithm. So our first function here, f of x, is equal to e to the 2x times the natural log of x squared. So the first thing we should notice is that we have a product going on. This function involves e to the 2x times the natural log of x squared. So we should be using the product rule as we go about finding the derivative of this function. So let's go ahead and get started. So f prime of x is equal to, and now we're using the product rule, so it will be the derivative with respect to the first factor times the second factor plus the derivative with respect to x of the second factor times our first factor. And now we need to go ahead and determine what these derivatives actually are. So notice that we have e to the 2x, so we will be using both what we know about the derivative of the exponential function along with the chain rule. We must use the chain rule because this exponent for our exponential function is more than simply x. So we're going to end up with the derivative of an exponential function is that exponential function, so e to that power or e to that argument times the derivative of that exponent. So the derivative of the 2x times the natural log of x squared plus, now similarly we need to use the chain rule when we find the derivative of this natural log. Notice that the argument to the natural log function is more than simply x, so we will need to use the chain rule here as well. So the derivative of the natural log function is 1 over the argument times the derivative of the argument. And our argument in this case is x squared. Then multiply that by the e to the 2x. Okay, so now our derivative is equal to, now the derivative of 2x is simply 2, so we're going to have 2 times e to the 2x times the natural log of x squared plus, now the derivative of x squared is 2x, and notice we have a 1 over x squared times a 2x. So we can actually simplify a little bit and divide out one of those factors of x. And so we end up with 2 over x times e to the 2x. And there's our derivative. Now let's look at our second function. We have x cubed times log base 10 of 2x. So again, let's notice that we have a function called that is x cubed times a function that is log base 10 of 2x. So we will be using the product rule again. So let's go ahead and find our derivative. So f prime of x is equal to, by the product rule, I will take the derivative of the first factor, the x cubed, times log base 10 of 2x, plus the derivative of the second factor, the log base 10 of 2x, times the first factor, which was our x cubed. Okay, so now we need the derivative of x cubed, the derivative of x cubed is 3x squared. So f prime of x is 3x squared times log base 10 of 2x plus, and now we need the derivative of log base 10 of 2x. Well, the derivative of log in any other base than e is 1 over the natural log of that base times the argument of that log function times the derivative of that argument, which is in this case 2x, all of that times x cubed. So f prime of x is equal to 3x squared log base 10 of 2x. And now when we take the derivative of our argument, our 2x, notice that that is going to give us simply a 2. And now notice that we have a 2 in the denominator and a single 2 in our numerator. And we can actually simplify that 2 out of both the numerator and the denominator. So in our numerator, we have 1 times x cubed. So that's going to give us an x cubed. And in our denominator, we have a natural log of 10 times 1, which is simply the natural log of 10. And there's our derivative of that function. I hope this is helpful.